Let me welcome you all to a new edition of Physics. In this edition, we'll try to solve problems on Chapter 1. The problems are of gradual difficulty. I'll start with very easy problems, then the problems will be a little bit more difficult. So let's get started. Problems on Chapter 1. We'll start with very easy problems. And now we've got the question, what's meant by resistivity of copper at a given temperature is equal to 1.69 times 10 to the power of negative 8 ohm meter. Okay, if I give you this piece of information, resistivity of copper is equal to 1.69 times 10 to the power of negative 8 ohm meter. What do you understand from it? Okay, thank you very much. It means resistance of a copper wire 1 meter in length and 1 meter squared in cross-sectional area at that temperature is equal to 1.69 times 10 to the power of negative 8 ohm. And now talking about conductivity of a material. It is sigma. It is the reciprocal of resistivity. So it depends on two factors only, kind of material and temperature. It is the reciprocal of resistivity. Sigma equals 1 over rho E. So unit of conductivity is ohm negative 1, meter negative 1. Ohm negative 1 is called Siemens, by the way. Okay, so unit of conductivity once again, ohm negative 1, meter negative 1, or Siemens, meter negative 1. Resistivity of a material, as I said, depends on the kind of material and temperature. And now we've got another question, what's meant by conductivity of silver at a given temperature. Conductivity is equal to 6.173 times 10 to the power of 7 ohm negative 1 meter negative 1. It's all easy. All you have to do is to convert it into resistivity. Resistivity equals 1 over conductivity. So rho E equals 1 over 6.173 times 10 power 7. It is 1.62 times 10 power negative 8 ohm meter. And now we can say, yes, the resistance of a wire of silver 1 meter in length, 1 meter squared in cross-sectional area at that mentioned temperature is equal to 1.62 times 10 power negative 8 ohm. We've got a question here. What would happen to the readings on the 2 voltmeters if the value of R1 was increased? Okay, we'll increase the value of R1. We want you to say what will happen to the readings of voltmeter V1 and that of V2. As a matter of fact, increasing R1 will increase V1 but will decrease V2. So V1 increases but V2 decreases. And let's explain it. So since the current through the battery is calculated from V battery over R equivalent of the whole circuit, and V battery is constant, of course, so we've got an inverse relation between the current and R total or R equivalent, since V battery is unchanged. Okay. And since V internal is calculated by IR, IR is small, so V internal is proportional to the current, simply because small r is constant. V internal is directly proportional to the current, okay, and the current is inversely proportional to the total resistance. Okay. V battery is equal to V external plus V internal. V battery is constant, so V external plus V internal is equal to a constant, and this means when V external increases, V internal must decrease. Okay. So When V internal decreases, the external voltage increases. Okay, we'll take it from the very beginning. When R1 increases, increase in R1 will increase the total resistance. The current through the battery decreases. Okay, and internal voltage depends on the current. It decreases. When internal voltage decreases, external voltage increases. Okay. And what about the reading of the second voltmeter, V2? It depends on the current, simply because R2 is constant. So it is proportional to the current. What happens to the current? The current decreases, so it decreases. So V2 is proportional to the current, R2 is constant, so when the current decreases, V2 decreases. Further example for explanation of the previous idea, but we'll explain this but using figures, numbers, okay? In front of you, we've got a battery of 12 volt. Okay, V battery is equal to 12 volt. Internal resistance of the battery is equal to 1 ohm. We've got, yes, variable resistance. The value, chosen value is 2 ohm. And by the way, we'll change it, and instead of 2, it to be 12. Okay, and we've got a resistance of 7 ohm. V2 measures the potential difference across R2. V1 measures the terminal voltage. Okay. R equivalent of the whole circuit, or R total, it is 7 plus 2 plus 1. 1 is the internal, it is 10 ohms. Okay, so the current through the battery equals 20 over 10, it is 2 amperes. V external is calculated from the expression V battery minus IR. So it is equal to 20 minus 2 times 1, it is 18 volt. Keep this figure, this number, yes, keep it on mind. Okay, and what about V2? It is calculated by IR2. It is 2 times 7, it is 14. So terminal voltage 18, voltage across the resistors, the 7 ohm resistor, it is 14. And now we'll change R1 instead of being 2 ohms to be, yes, 12. We'll increase it and we'll see the effect of this on the terminal voltage V1 and on the voltage V2. Okay, total resistance, it is 7 plus 12 plus 1, 20. Current through the battery, V battery over R equivalent, 20 over 20, 1 ampere. Now V1, which is V external, equals V battery minus IR small. 20 minus 1 times 1, it is 19. You remember the previous figure, it was 18, so it increased. V1 increased when we increased the value of R1. And what about V2? It was 14, and now IR2, 1 times 7, it is 7, so it decreased. So increase in R1 will, yes, increase V1, but it will decrease V2. Okay. Another question, what would happen to the readings on the voltmeters if R1 was increased? But in this circuit, in this example, we've got something special here. Internal resistance is equal to 0. So what happens when internal resistance is equal to 0? V1, which is terminal voltage, will be equal to V battery. Okay, V battery changes when we change the battery. We didn't change the battery, so V1 will be constant. It won't be altered. Okay, this is very important. Internal resistance is equal to 0, so V external is constant since it is equal to V battery. What is the effect of increasing R1? Okay, V1 is equal to V battery simply because IR is small, V internal is equal to 0. So V1 remains unchanged. And what about V2? V2 is calculated using the formula IR2. Yes, when R1 is increased, by increasing R1, current will be decreased and V2 will be decreased. Okay, V2 is proportional to the current. R2 is constant, of course. So what happens to the current? The current decreases, V2 decreases. Okay. When R1 increases, the current decreases. Okay, so V2 decreases. And what about V1? V1 remains unchanged. Why? Because it is equal to V battery. Why it is equal to V battery? Because the internal resistance is equal to 0. Another question, what would happen to the readings on the voltmeters if R1 was increased? Okay, what about this example? Something very special here. V1 actually is equal to V2 because both of them, yes, measure external or terminal voltage. Okay, there is a trick here, but you are clever enough, you're smart enough to know it. V1 actually is equal to V2. V1 and V2, each one of them is the terminal voltage. Okay, so what happens when R1 is increased? When R1 is increased or when R1 increases, the current, yes, of course, the current decreases through the circuit, of course, decreases. And internal voltage depends on the current, and it is proportional to the current. Current decreases, internal voltage decreases. And when internal voltage decreases, external voltage should increase because the sum of both of them is constant, which is V battery. So V1 increases, and of course V1 is the same as V2, so both of them will increase. Note, we've got something here, something interesting. In the previous circuit, previous example, if R was equal to 0, what if the value of R is equal to 0? And, oh, okay. Then V1, which is V2, which is equal to V2, will be equal to V battery, and V battery is constant. So by changing R1, yes, the value on each voltmeter will not be changed. Okay, so in this particular case, when R is equal to 0, V1 will be equal to V2, and each one of them will be equal to V battery. Okay, and since V battery is constant, so V1, V2 remain unchanged when R1 is changed. Another example, what would happen to the readings on the voltmeter if R1 was increased? Your attention, please. The most important thing is to determine what actually the voltmeter measures. It measures the potential across R2. In front of you, the voltmeter shown in front of you on this particular case measures the potential across R2. Okay? And it depends, it is equal to IR2. R2 is constant, so it depends on the current. It is proportional to the current. Okay. The voltmeter actually reads the voltage across R2. The reading on the voltmeter equals IR2, as I said. When the value of R1 is increased, the current decreases. So the reading on the voltmeter, which depends on the current, yes, decreases as R2 is constant, unchanged. Okay? So when R1 is increased, the current decreases, V1 decreases. Another example, what would happen to the readings on the voltmeter and the meter when the switch is closed, key 2 is closed? Okay, when the switch is closed, we are disconnecting R1. The resistance, denoted by R1, is eliminated, removed from the circuit. Okay, so we are decreasing the resistance. So the current must be increased. So reading on the ammeter should be increased. And what about the reading on the voltmeter? The voltmeter reads the terminal voltage. Okay. And what about the terminal voltage? Okay, it is inversely proportional to the current. The current increases, terminal voltage decreases. Okay, let me say it again. V decreases, reading of the voltmeter decreases, but reading of the meter increases. Once again, when the switch is closed, we are actually disconnecting R1. Okay, so we are decreasing the resistance. Current increases. When current increases, terminal voltage decreases. And now we've got a problem, a galvanometer of the resistance 10 ohms. So Rg is given to be equal to 10 ohms. Gives its full scale deflection. Full scale deflection is Ig. Gives its full scale deflection when a current of 500 microampere passes through its coil. This is Ig. 500 micro should be converted into ampere, multiplied by, yes, thank you very much, 10 to the power of negative 6. So the device gives its full scale deflection when a current of 500 microampere passes through its coil. Explain how to convert it into an ammeter that reads up to 1 ampere. 1 ampere is I. The maximum current read by the ammeter is I, so I equals 1 ampere. How to convert it into, yes, a voltmeter that reads up to 10 volt. 10 volt is V. Okay. So once again, given in the problem, the resistance of the galvanometer is equal to 10 ohms. Ig full scale deflection 500 micro, so 500 times 10 power negative 6 ampere. Current required to be measured, maximum current is 1 ampere. We'll use, yes, the expression, the relation of the shunt. Okay, Rs is equal to Rg over I minus Ig. So it is equal to 500 times 10 to the power of negative 6 times 10 over 1 minus 500 times 10 to the power of negative 6. Value of the shunt is equal to 0.005 ohm. So we have to add something very important here. We should mention the way the resistance should be connected to the coil of the galvanometer. So a resistance of 0.005 ohm is connected in parallel to the coil of the galvanometer. Okay, second part of the problem, we wanted to measure, yes, voltage. Okay, so we want to convert it into a voltmeter. We'll use, yes, the formula of the multiplier. Multiplier is equal to V minus Ig Rg over Ig. Maximum voltage required to be measured is equal to 10 minus 500 times 10 power negative 6 over 10. Ig equals, yes, 1 minus 500 times 10 power negative 6. So the value of the multiplier is equal to 19,990 ohm. So a resistance of 19,990 ohms should be connected in series to the coil of the galvanometer. Value of the required resistor, required shunt resistor to decrease the sensitivity of an ammeter of resistance 24 ohm to its 1/4, 1/4. Okay. What is the value of the total resistance of the ammeter and the shunt? Resistance of the galvanometer equals 24. We want to reduce sensitivity to 1/4. This means that, yes, I equals 4 Ig. Ratio between Ig to I equals 1/4. So I equals 4 Ig. Value of the shunt is given from the expression Ig Rg over I minus Ig. So Ig, okay, times resistance of the galvanometer 24, I equals 4Ig, so 4Ig minus Ig. So we can say 24 Ig over 3 Ig will be crossed out. In this way, we've managed to obtain the value of the shunt. And what about the resistance of the ammeter, the device produced? It is a galvanometer and a shunt resistance connected in parallel. So resistance of the ammeter is obtained from product over the sum, 24 times 8 over 24 plus 8, it is 6 ohm. Okay, what about the first problem? In front of you, we've got a circuit, a battery, and two resistors, 3 ohm resistor and 2 ohm resistor. Current through the battery is denoted by capital I, and that through the 3 ohm resistor is I1, and that through the 2 ohm resistor is I2. Okay, internal resistance of the battery is equal to 0. This is very important. And we want to calculate I1 and I2, also the total current. It's all easy. On this particular case, we've got two resistors connected in parallel to 6-volt battery. Okay, so the voltage of the battery, the whole voltage is applied across the two resistors. So it's all easy. I1 is equal to 6 over 3. It is 2 amperes. I2 equals 6 over 2. It is 3 amperes. And of course, the total current will be equal to the sum of both of them. It is 2 plus 3. It is 5 amperes. Okay. Another problem. We've got a circuit. And what about the circuit? It consists of a battery, but the value of the battery, value of the EMF is unknown. Internal resistance is given to be equal to 1. We've got a resistance of 2 ohm connected in parallel to 1 ohm. Current through the 1 ohm resistor is equal to 2 amperes. We want to calculate EMF of the cell. Okay. We've got two resistors connected in parallel. So potential difference across, yes, them is constant, it's the same. Potential difference across the 1 ohm resistor can be calculated. It's all easy. We know the value of the resistance. It is 1 ohm. Current through it 2 amperes. So voltage across the 1 ohm resistor is 2 volt. Voltage across the 2 ohm will be also 2 volt. And knowing the voltage and the value of the resistance, we can calculate the current. So current through the 2 ohm resistor, it is 2 voltage across 2, it will be 1 ampere. 1 ampere plus 2 ampere will give the total current. Total current multiplied by the total resistance will give the V battery. So let me do it once again. Potential difference across the 1 ohm resistance, it is 2 times 1. It is 2 volt. Potential difference across the 2 ohm resistor, it is 2 volt also. And now we can calculate the current through the 2 ohm resistor. It is 2 divided by 2, it is 1 ampere. 1 ampere flows through the 2 ohm and 2 amperes through the 1 ohm resistor. So the total current must be equal to 3 amperes. Total current equals 1 plus 2, it is 3 amperes. And now we can calculate, yes, the EMF of the cell. It is equal to V external plus V internal. Okay, V external plus IR small. So it is V external is equal to 2 volt plus 3 times 1. It will be 5 volts. So EMF of the cell is equal to 5 volts. Another problem. We've got a circuit shown in front of you. V battery here is equal to 4 volt. R internal 0.5 ohm. We've got a parallel combination okay, which consists of 3 resistors, 8 ohm resistor and another 8 ohm resistor and 4 ohm. Okay, and this parallel combination is connected in series to 1.5 ohm, and do never forget the internal resistance of the battery is 0.5. Okay, calculate the current through current I1, I2, I3, and the total current I1 through the 8 ohm resistor, I2 through the 8 ohm resistor, and I3 then the total current. So the first step here is to calculate the total resistance. First of all, we'll calculate R equivalent of the parallel group. So 1 over R equivalent of 8 and 4, it is 1 over 8 plus 1 over 8 plus 1 over 4. Now I am calculating or trying to calculate R equivalent of the 3 resistors connected in parallel. 1 over 8 plus 1 over 8 plus 1 over 4, it is equal to, yes, 1 over 2. So R equivalent is 2 ohm. So R equivalent of the resistors 8, 8 and 4 is equal to 2 ohm. 2 ohm is connected in series to 1.5 and to 0.5 internal resistance. So total resistance of the circuit 2 plus 1.5 plus 0.5, so it is 4 ohm. Now we can calculate total current. Current, we call it through the battery. We call it the total current. So total current equals V battery over R equivalent or R total of the circuit. It is equal to 4 over 4. Total current equals 1 ampere. Current through the battery equals 1 ampere. Okay, to calculate I1, I2, I3, we need to calculate the potential difference across this parallel combination. Okay, it is equal to I, the current entering the parallel combination, times R equivalent of this parallel combination. So it is 1 times 2, it is 2 voltage. Now it's all easy to calculate the current through each resistor. Okay, so I1 is equal to the voltage over the value of the resistance, 2 over 8, which is 1 over 4. The same for the second, the other 8 ohm resistor. Okay, 2 over 8, it is 1 over 4. And 2 over 4, it is half amperes. Okay, in this way we've come to the end of this edition. Until we meet again, my best wishes to you all. Thank you.